Hello, everybody. Welcome to CIS125 Discrete Applied Mathematics. And this is Professor Bob. Before you get into the rest of the reading and the assignment, kind of where we're at with this. Now, most of you have been really busy over the past couple weeks getting the assignments done. I gave you the assignment on looking at z-scores, or basically probability theory, with making predictions based on descriptive discrete math. That was a tough assignment. It really was. All of you are up for the task. The thing is, though, with that sort of discrete math, especially when we're dealing things with distribution, probability theory, z-scoring, there's a lot that goes in there. It's very dense math, as I was explaining before. So it takes a little bit to sink in. And so it's taken a little bit for us to kind of get through that together. And I'm still kind of working through that with a lot of you. What I'm going to do is kind of a little bit of a departure from things I'm used to doing is I'm going to record the solution for especially the test scores. You know, if Bob, Cassie, and Cadence got like a 91, a 92, and 93, and I don't got the assignment right in front of me, so if my numbers are off, I apologize. And if the mean score is 75 with a standard deviation of whatever, what are the odds, or make your prediction of the percentile of Bob, Cadence, and Cassie, and make a conclusion on that. Now, I'm going to go over that with a video in the next day or so. So be patient. You guys know the drill. Just keep looking at the assignment and you'll see it there. I'm not going to really give you an email reminder because you know me. There are really no reminders. You know where to look and you know where to ask questions. But anyway, and I'll go over the steps in that. So if you're still working on that, continue to work on that, and we're going to get you through it. It is kind of important, and it does open up your mind, if you will, for kind of get those neurons connected to start thinking mathematically, especially about things like that. So that's where a lot of you are. So for those of you that have been that got that done, it kind of seemed like a little bit of a 2-week hiatus for you. So good for you. You're ahead of the curve. Hopefully you did something fun. And now it's kind of time to get back to things. This class is about getting it right, not about getting it on time and not be right. I'd rather you spend some extra time on it and not feel stressed about it. Believe me, there's enough stress in real life. There's enough stress when you're doing these things for real. This is not the time for that. The time for this is to kind of learn it. The same neural pathways that you develop doing math like this are very similar to learning other abstract things, like music. If any of you are musicians, you know what I'm talking about. You can't cram for your piano lesson. You can't, or like me, I'm learning how to play cello, and I can't cram for that. I can't say, oh, you know what, I'm just going to wait till Tuesday, and I'm just going to buck up, and I'm going to get it done, and I'm going to pull an all-nighter and drink some coffee and get it done. It doesn't work like that. You need to do these things in small doses. You need to have a time component between these sessions where you look at it, you're like, you know what, I've had enough. I need to take a break, drink something cold, surf the web, do something mindless, like, watching, Keeping Up with the Kardashians or, Married at First Sight, which are two of my binge favorites lately. So please do that. That's not giving up. That's giving your mind time to heal. That's giving your mind time to kind of like redo itself. For those of you that work out, I'm not one of them, but from what I understand, you can't just cram all of your workout sessions in one period of time. You work out, you have your regimen, you work out 5 days a week for an hour at a time, half an hour, and then there's a time for your body to recover. You drink some protein, you get some rest, whatever your regimen is. Your body heals, it builds new muscle, and then you go at it again. Your brain works exactly like that. When you're doing math like this, it's maddening because sometimes you want to just get some steps. You're like, all right, well, what do I do? Well, there are steps, sure. You look at your normal distribution, you look at your deviations, you look at your formulas for your variance, and you look at your deviations for normal distribution, then you plot things out. So there are steps to go through, but more importantly, it's what you do between those steps. It's what you do between those steps, the critical thinking that leads you from step 1 to step 2 to step 3. So at some point, it stops becoming a checklist and it starts becoming more critical thinking about how you get from one point to the next. And that's where I think a lot of you didn't get when you were in middle school or high school. And I'm not blaming you. I'm not blaming your teachers. I'm kind of blaming the system and how math is taught, because I don't think that we as math teachers do a really good job of it. I think we, it's reading and writing and arithmetic, and 9 times 9 is 81, and we do times tables, and we do division, and we take tests, and we talk about percentiles, and we forget really what we're trying to do, what we're trying to accomplish. And when we put things in that sort of perspective, the math becomes easier. It really does. Math is not hard. We're wired to learn it. When we were living in caves or in plains and we were hunting and gathering and we were constantly doing math, how long does it take to get to the lake to catch a fish? And if we walk 3 days and we catch so many fish, how many fish are we going to have for the people we need to share it with? When we look at the sky and we count the stars, or we count the time between the sun comes up and the sun comes down, we notice at a very early age in our development that, that days got longer and then nights got longer, and there was an ebb and a flow. Then we learn to count. We learn to count minutes. We learn to count hours. And then we would divide that by how long it would take to see the seasons come and go. So we came up with years, and we divided that into months, and we divided that into days, and then we all had birthdays, and we started developing mathematical systems based on everything that was around us. So that's still in you. It's still all in our heads, and it's easy to kind of forget that. If we could kind of like dig deep in there, we can find that again. So that's kind of where I'm going to be at this week with our assignment. Now, our assignment this week is a little bit of a departure from an answer, because that's what we've been doing so far. Is with the discrete math we've been doing so far is we have an answer. What is the answer to these questions? I want you to stop thinking about that for a week and start thinking about the process of coming up with math and understanding math and how it describes the world around us. The title of this course is Discrete Math. Now, we talked about discrete math in a little bit of depth in week 1, where when we talk about discrete math, we talk about math with no gaps between it. We talk about natural numbers, 1, 2, 3, -1, -2, with no space in between it. And that's discrete math, because for example, if you looked at how many years old you are, and you didn't count the time between it, like, I'm 29 years old. Okay, that can happen, right? And next year I'll be 30, the next year I'll be 31. If we didn't count the spaces between that, we have a discrete math numbering system. Temperature is like that too, if we ignore the space between things. Now, there is a big difference between discrete math and non-discrete math. Now, non-discrete math means that we talk about the spaces between things. So when we deal with a lot of decimals, we're dealing with non-discrete math. When we're dealing with extremely small numbers and extremely large numbers, we're dealing with non-discrete math. So your assignment this week is to look at a mathematical problem and determine if it's discrete or non-discrete. Is it divisible or is it not divisible? And that's a very interesting mathematical concept, because with mathematical concepts, we deal with the concept of divisibility, right? Everything's divisible by something. If it takes you, how about this? If it takes you an hour to finish your homework assignment, or if it takes you an hour to drive to work, what if it took you half that time? Well, it would take you 30 minutes. That's discrete math, right? We're dealing with divisibility, right? And we're dealing with whole natural numbers. Now, let's continue that. And let's just say it takes you 30 minutes to do your assignment or 30 minutes to drive to work. What if it takes you half as long? It will take 15 minutes, right? You're all rolling your eyes. Duh, Bob, I got this. But let's continue this. This is where discrete mathematics become non-discrete. Okay, so if we keep dividing by 2 and we keep saying that it takes you half the amount of time to drive to work or half the amount of time to do your assignment, when do we ever get to 0, right? Think about it. Now, when we deal with 15 minutes, if we divide that by 2, it takes 7.5 minutes to drive to work or do your assignment. Okay, we're speeding up. We're going a lot faster now. But now we're getting from discrete math into non-discrete math. Not a good thing or a bad thing. It's just a boundary we're catching. I'll remember, discrete math is just a definition. Okay, so now we're into non-discrete numbering systems. Now we're in 7.5. Divide that by 2, what do you get? Divide that by 2, what do you get? How many times can you divide your time by 2 until you get to 0? Think about it. Like Jeopardy. No, 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 no. The answer is it's infinite. You have an infinite numbering system where if you keep dividing by 2, you never get to 0 because there's always space between those numbers, right? I mean, even if you got 0.1, 0.2, 0.3, there's space between 0.1 and 0.2. Divide that by 2, there's still space between them. So you get to a numbering system that becomes finite and infinite and discrete and non-discrete all at the same time. So for this week, I want to blow your mind a little bit with that theory, okay? I'm not going to ask you for an answer. I want you just to let your guard down and open up your mind mathematically to all things possible. And I want you to do your reading and take a look at what we would consider a discrete numbering system versus a non-discrete numbering system. And I have just a little bit of a essay for you, short answer session. Don't get scared. I want to hear what your opinion is. I want you to put in some original thought and tell me what you think. All right. Thank you very much for your time. If you have any questions, please reach out to me. And I bid you all a very well rest of the day. Thank you.